All right, so we're going to quickly take a look at the parameters of exponential functions and just a couple of highlights that I want to make sure that you understand. If you're looking at a growth exponential function, and again, how do I know if an exponential function is growing? If b is greater than 1. So at this point, you should know that a, b, shift 6 to the x power. If b is bigger than 1, it is growth. If b is between 0 and 1, it is decay. So again, here we go. You have a, b, x, and then we do have a plus c. So let me just quickly review a couple of things that we've been doing for a long time. To find the y-intercept, it's going to be a plus c. A lot of the times there's nothing there, and if there's nothing there, it's 0. So sometimes it's just a on its own. B is your growth if it's greater than 1. And the way you can tell if you have some fractions, like here, if the numerator, which means the top number, is bigger than the denominator. So if the top number is bigger than the denominator, then it's growth. So for example, this one is bigger than that one, so it's growth. If it's decay, the denominator is the big one. So in this case, you see the denominator, the bottom, is bigger than that. So if you have a small number on the top, it is decay. If you have a big number on the top, then it is growth. So it's just a quick way of seeing that. Alternatively, of course, you can definitely type it into the calculator and you can see the same thing. So you can see this number is smaller than the denominator, so it's decay. So you can use the calculator just to make sure. All right, and then the other thing is just the letter C is your isotope, and it must always be y equals whatever C is. Okay, so in this case, I don't see any C's, so what does that mean the isotope is? 0, and look at that. The isotope is a 0. The graph approaches but never touches 0. Okay, so that's just a quick recap. And then in terms of B, so whether it's growth or decay, there's some things that you need to remember. And if you don't remember them, you can always type it into the calculator. So for example, if I think, once I know it's decay, I can just put some different decay numbers in there and see what's happening to that graph. So for example, it says type in 100 and then 1/2, right? And then to the power of x, so shift 6x. All right, so you're going to type in the same thing a couple of times. So I'm going to get rid of this and see what happens to it. So right now it's exactly the same. So 0.5 is a decay problem because it's between 0 and 1. If I make it a quarter, right, it's an even smaller problem. If I make it a sixth, it's an even smaller number. And again, if you don't know your fractions, you can go ahead and put them in decimals and compare the decimal formats of it. So you see that that's 0.5. You see that this is 0.25. And you see that this one is 0.166. So these fractions are getting smaller. So what happens as I get smaller to my graph? Okay, so I like to vision this like a slide, like you're going down a water slide. Boom. So you can see that this water slide is very, very steep, whereas this one is more of a gradual steepness. So the smaller the number, so you see this one is the smallest, the smaller the number, the steeper the water slide. And that's what I need you to remember. So when you're looking at decay, the smaller the fraction, the faster it is decaying. That's not growth, decays. So I'm making sure that I'm showing you different numbers like 1/2, 1/4, 1/6, because if you forget this little saying that says if it's decay, the smaller the fraction, the faster it decays, the steeper the slide. If you forget that, you can make up your own fractions, it doesn't matter, and just see what happens as my fraction is super, super small. So what happens when my fraction is small compared to not so small? And then you'll see again, then you'll remember what this is. So again, I'm showing you how to just make up some random numbers and see. For growth, the bigger the number, the faster it grows. And you can also look at it as it's the closest to the y-axis. Now, again, I can just make it up. And I don't even have to have, like, I just make the same start, but you can make it 10. You can make it any number, just make it the same. And then here I want it to grow. So growth means number bigger than 1. So I'm going to pick 2. And I want to see what happens as it gets bigger. So let's say 5. And then what happens is it gets bigger, 7. So this way I'm showing you, if you ever forget this rule, the bigger the number, the faster it grows, the closest to the y-axis, you can put it into decimals yourself and look. So purple is 2. So this one is 2. As the number gets bigger, 5 is black right here, and then 7 is red. As the number gets bigger, what happens to my slide? It gets really scary. This one is a little less scary, but this one is super scary because it's super steep. And then the other way you can also look at it is it's closest to the y-axis. The one that's closest to the y-axis, right, is my steepest one, is the most scariest one. All right, so those are the two shortcuts that you need. And if you forget how to do them, you can make up your own numbers in decimals and look at it. Now let's actually do questions based on that. So based on this, let's match the exponential function to its graph. So we have exponential functions, a few things that we are looking at. We're looking at the y-intercept. We're looking at the isotope. And sorry, the y-intercept is a plus c. We're looking at just the isotope, and then we're looking at growth and decay. So in this case, I see the isotope on everything is 0. That means all of it approaches 0, which doesn't help me. If I look at the y-intercept, a is invisible 1, because if I have a 0 here, 0 multiplied by anything will be 0. So this is invisible 1, invisible 1. Here, again, invisible 1, because the one attached to the x is b. Here, invisible 1, so that doesn't help me. But in some questions, it will. So on this one, I just have to go straight to what is b doing. So I see that from left to right, this is growth. From left to right, this is growth. From left to right, this is what? Decay. From left to right, this is decay. So there's 2 growth and 2 decays. All right, so for growth, I know b is bigger than 1. If I have a fraction, the top number is bigger than the denominator. This one is not growth. This one is. The bigger number is bigger than the denominator. Perfect. So this one is a growth. This one is growth because it's 2. And then this one is decay. So I got 2 decay problems right here. So these 2 match here and these 2 match here. Now that I have 50-50, now let's match it. This one you can see is steeper. It's a scarier slide to come through. This one is more like, oh, la, 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 right? So the steeper one for growth is the one that is the biggest number in B. So these are my 2 growth. I have 2 and then 4 divided by 3. If you don't know what that is as a fraction, you can definitely type it in and see what happens. So that's 1.33. Between 1.33 and 2, which one's bigger? This one. So this one is the steeper one. So the one that's closest to the y-axis. Like if I look at the number 5, for example, I'm going to see 1, 2, and a little bit. But if I look at the number 5, which is right here, 1, 2, 3, 4, this is further away. So the bigger number is the steeper one. So this one is going to match with that. And this other one is going to match with that. Okay. And actually, just for clarity, let's not do it with arrows because that's going to get confusing. Let's just put it in. So the bigger numbers, so this is going to be 2 to the power of x, and then this one is 4 over 3 to the power of x. All right, then for my decay one, remember it's opposite. The smaller the fraction, the faster it is sliding. So I can see this one is the more scary slide. All right, this one is a little bit easier. But again, just pick a number. So I'm picking 7. I'm going to go 1, 2, and a little bit. Here's 7, 1, 2, 3, 4, 5, and I'm still not there, right? So this one is the steeper. So I'm looking for the smallest fraction. Between 3/4, if I have 3/4, I have how many cents? 75 cents. And if I have half a dollar, I have 50 cents. So the smaller the number, the steeper the problem. So this one is 1/2 to the power of x, and this means that this is 3/4 to the power of x. So practice is going to make perfect in this question. So I'm going to go ahead and pull up some practice problems, and we're going to kind of work through it, and I'll use a calculator where I need to. All right, so match each exponential graph. So you can see from left to right, this is doing what? Growth. This one is doing what? Decay. This one is doing what? Growth very slowly. This one is doing what? Decay very slowly. So I got 2 growth, 2 decays. So that's what I'm looking for here. All right, 9 out of 10. This is smaller than this one, so I know this is decay. 1 out of 4. This is smaller, so I know this is also decay. So here are my 2 decays. I don't even need to know what these fractions are to know which one is faster. The smallest number is this one because it's less of the fraction. 1/4 is less than 9/10. 9/10 means I only got 1/10 left. So this one is very, very close to be completely 1. This one is 0.25. So the smaller the fraction, the steeper the decay. So this one's a gradual decay, and here's a steep decay. So this one goes with that, which means the smaller the number, the steeper the decay, or closest to the y, and then the bigger the fraction, the more gradual it is. And I can double check that by typing this in decimals. So if you do need decimals, go ahead and by all means use it. I'm trying not to type it into decimals each time, but you can definitely do that. You can see this is very close to 1 because it's 9/10. It's only 1/10 away, where this is 3/4 away. Okay. All right. So for my growth, I got 4, and then I got 10 divided by 9. I don't know what 10 divided by 9 is. That's okay. You can go ahead and type it in. If I take 10 and I divide it by 9, it's going to be a really small number because it's not that many 9's going to 10. Like 9 goes into 10 one time in a little bit. So again, I don't have to use Desmos, but if you do need to, you're completely lost as to what I'm doing, you can just put it in Desmos and then just go from there. So I know this is like very close to 1, so that's going to be my small one. This one is 4, so it's going to be my big one. So my small one is the smaller the number, or the bigger, let's remember one way. The bigger the number, the steeper my slide. So this one is steeper than this one. So this one goes there, and that one goes there. And then you just submit your answer. And we're just going to practice a few of these until you kind of get the idea of it. I'm actually even going to skip a level to see if it changes. Oh, good. Look at this. It changes. So sometimes you can use the y-intercept as well to give you a shortcut. Because look, what do I have here? A, and my isotope is still 0, so the isotope doesn't help me, but 4 plus 0 is still 4. And this one, the intercept is 2. So those are the only ones that are different. So I can go to, where's my intercept 4? Right there. I don't even have to look at how my B is doing. Where's my intercept 2? That's 1. My intercept right here is 2. The rest of these, the intercept is invisible 1, right? Now I can look at these two. One of this is decay. How do I know it's decay? Because it's between 0 and 1. So this one is decay. So looking at the two problems, what's this? Growth. And this one is decay. So I don't even have to really take a lot of time into doing these questions if I really understand what ABX plus C means. Again, we have different, let's see, these all y-intercepts are 1 and all c's are 0. So this one you have to look. This is growth, decay, growth, decay. So 2 decays, 2 growths. So I can see right here, this is decay. This one also is decay. So this one's growth and that one's growth. All right, so let's do the growth one. The bigger the number, the steeper the slide. So this one and this one, this is the bigger number, the steeper the slide. So this one right here, see it's sliding, the steeper the slide, where this one is not sliding very much, right? So the closer to the y-axis, if that helps you see it. So pick a number, here's 8. 1, 2, 3. Pick a number 8. 1, 2, 3, 4, 5. I'm going to be going forever before this line gets anywhere close up there. So the bigger the number, the steeper the slide. The smaller the number, then the steeper it is. All right, here are my 2 decays from left to right. They're going down. This one obviously is steeper. It's closest to the y-axis, right? This one is really far from the y-axis. And for decay, the smaller the number, the steeper the slide. So the smaller the number, the steeper the slide. And all this is going to take is just a little bit of practice. Again, if they give you, again, isotopes are all 0, but intercepts are 2, 2. So that one, they're going to be 2 that are the same. One's growth, one's decay. And then there's 1 that's 3, so I can go get the 3 one. Here's a 3. 1/3, so that's in between 0 and 1. So there's only 1 right here. And then here are my two that are 2's. Which are both, but one is growth, one is decay. Which one's growth? The 2 is growth, so left to right going up, and that is decay. So sometimes you don't even have to put in looking at what's happening to B to be able to answer these questions. And look, just like anything else, practice makes perfect. Let's practice.